You know how sometimes you see a math trick and it just feels like actual magic? Well, today we're going to pull back that curtain. We're going to crack the code, and you'll see that what looks like magic is really just the incredible, predictable power of algebra.
All right, to kick things off, I'm going to need you to play along with me. So, go ahead, grab your phone for its calculator or a piece of paper. Let's do this together. I promise, you're going to be surprised by the result. You ready? Okay, first up, a little math magic. We're actually going to use your phone number for this one. But don't worry, I can't see it or anything. This is all for you.
All right, just follow these 6 steps with me. Step 1, take the first 3 digits of your phone number, not the area code, and multiply that by 40. Got it? Okay. Step 2, just add 1 to whatever you have. Easy enough? Step 3, take that whole new number and multiply it by 500. Now, for step 4, a little different. I want you to add the last 4 digits of your phone number, and then add those same 4 digits again. Yep, twice. We're almost there. Step 5, subtract 500 from your total, and for the grand finale, step 6, divide that entire thing by 2.
Okay, go ahead, take a look at your final number. Does it look familiar? It should be your 7-digit phone number, just sitting there, perfectly put back together. How cool is that? But here's the thing. It's not a coincidence, and it's definitely not magic.
So how? How in the world did that seemingly random set of calculations manage to put your specific phone number back together? Well, the secret, it's algebra, one of the most powerful tools in all of math. So let's break down exactly what just happened.
All right, section 2, the power of variables. The whole trick we just did, it all comes down to one single concept, and it's really the heart and soul of algebra, the variable. It's this amazing idea that lets us work with numbers we don't even know.
So what is a variable? Think of it like a placeholder. It's just a symbol, usually a letter, like X or A or B, that stands in for a number. I mean, in our trick, I had no idea what your phone number was, right? So we use variables to represent the different parts of it. And that's the key. It lets us create rules that work for any number you could possibly pick.
Take this for example. A plus B equals B plus A. This is a universal truth in math. We call it the commutative property. And all it's saying is that it doesn't matter what numbers A and B are, you can add them in any order and you'll always get the same result. See? Variables let us write down these fundamental rules that are always true.
And this isn't just some abstract, high-level math stuff. We use variables all the time to describe how the world around us works, a lot of times without even realizing it.
I mean, think about finding the area of a rectangle. The formula is area equals length times width. We're using variables right there. L for length, W for width. That simple formula describes the relationship for every single rectangle in existence. It's a perfect everyday example of variables doing their thing.
Okay, section 3, simplifying the mess. So now we know what variables are, the next step is figuring out how to manage them. Because let's be honest, these expressions can get pretty complicated pretty fast. But the good news is, algebra gives us some really powerful tools to clean them up.
I like to think of it like tidying up your room, right? You put all your socks in one drawer, all your shirts in another. You group like things together. Well, that's exactly what we do in algebra. We group similar terms together, and this whole process is called combining like terms. It's what takes a big, messy problem and makes it totally manageable.
Here, check out this super simple example. If you have 4W and you add 3W, well, how many W's do you have? You've got 7W. It's really that intuitive. We've just taken a slightly longer expression and tidied it up into something shorter that means the exact same thing.
Now here's a super important point, a really common mistake people make. You got to remember that when you just see an x by itself, it's really 1x. So people sometimes think that 5x minus x just makes the x go away, leaving 5. But nope, that's not right. It's really 5x minus times 1x, which leaves you with 4x. And the big rule here, the key to the whole thing, is that you can only combine terms if they have the exact same variable raised to the exact same power. So you can't combine something like 20x squared with 2x. They're just different things. It's the whole apples and oranges idea. They're just not the same, so you can't add them up.
Okay, let's do this. Section 4, the trick revealed. We have our 2 secret weapons now, variables and simplification. It is time to go back and finally crack the code behind that phone number trick.
So, instead of your actual number, let's use variables. We're going to let A be the first 3 digits of your number, and B will be the last 4 digits.
Now, if we translate every single step of that trick into the language of algebra, this is what we get. I know, it looks like a total mess, right? But just watch what happens when we start to clean it up.
Okay, let's walk through this. Step 1. We distribute that 500 inside the parentheses. That gives us 20,000a plus 500. Now, step 2, we combine our like terms. And look at this. You have a plus 500 and a minus 500. Poof, they cancel each other out completely. That leaves us with just 20,000a plus 2b. So much cleaner. And now for the last step, we divide that whole thing by 2. And suddenly, that entire mass boils down to something incredibly simple.
And there it is, the secret. 10,000a plus b. Now, just think about what that means. Let's say your first 3 digits are a was 555. When you multiply that by 10,000, you get 555,000. See what it did? It basically just shifted those first 3 digits way over to the left, leaving 4 empty spots, 4 zeros. And then what do? We add b, your last 4 digits, and they slot perfectly into those empty spaces. Every single one of those crazy steps we did was designed to cancel everything else out and leave just this beautiful, simple formula. That's not magic. That's just some really clever math.
Okay, last section. Section 5. Algebra is everywhere. Because really, this isn't just about some cool party trick. These exact same principles, using variables to represent things and simplifying relationships, they're what we use to describe and even predict the world all around us.
I mean, look at one of the most famous equations in all of history, the Pythagorean theorem. A squared plus b squared equals c squared. That little formula uses variables to lay out a relationship that is true for every single right triangle in the universe. It's incredible! And it's not just for textbooks. This has super practical uses. Let's say you want to know the fastest way to get across a park. Well, the 2 sidewalks, they make a right angle, so that's your A and B. The shortcut across the grass, that's C. And algebra lets you calculate that exact distance, the exact shortcut, before you even take a single step.
And it's everywhere else, too. You want to calculate how far a car is going to travel? That's algebra. Figuring out the force needed to move an object, a total cornerstone of physics? Yep, that's algebra. Finding the area of a circle. You already know the answer. These formulas are basically the language we use to make sense of the physical world. So, next time you see something that seems impossible, something that feels like magic, just remember that phone number trick, because so often, right underneath the surface, there's a simple, beautiful, elegant structure just waiting to be explained. The real magic isn't the trick itself, it's having the tools to understand how it works.